In this lesson, we have a summaries of writing formulas for different types of substances. The first common types of substance that we have is an elemental metals or a pure metal substance. In this case, we use the element symbols to represent the elements metals. And then we have ionic compound that consists of metals and non-metals. When we have the naming, they do not use prefixes comparing to the covalent compound. And the first metals will always be a positive ions or cations, and the second element will always be a negative nonmetal ions or anion. For a covalent compound, we have a nonmetals and a nonmetals bonded together, and they use prefixes in their name to indicate the number of atoms. In this case, we don't have to use crisscross to balance out the charge because the covalent compounds only share electron. The electrons are not completely transferred between metals and non-metals. So the first elements use the name of the element on the periodic table, but the second element use the anion's name. Lastly, we have an elemental gas. They exist as diatomic molecules. So let's do one problem together. Over here, I have a summary of the PT where all the elements in group 1A will lose one electron and become 1 plus, 2A will become 2 plus, 3A will lose 3 electrons, become 3 plus, 4A either lose 4 electrons or gain 4 electrons. Then lastly over here, we have 5A, it will gain 3 more electrons to be octet. Over here 6A will gain 2 more electrons to be octet. 7A will gain 1 more to be octet. And here we have group 8A is already stable because it is already octet. So let's try one problem together. Here we have a description of a chemical reaction. So first of all, we have calcium, that is your elemental metals. So we have the element symbols for calcium, which is Ca, and react with, in this case, would be a plus sign. And copper chloride, which is Cu, because of the 2 right there, telling you that the charge is 2 plus, so we have Cu 2 plus, and chloride is in group 7A, so of course it's going to be Cl 1 minus. And look at the charges, 2 plus and 1 minus are not even, they do not cancel each other out, so we had to use a crisscross method to balance the charges. In this case, Cu will be just 1, and then Cl we would have 2. To produce, we use the arrow sign. In this case, producing copper, so it's going to be Cu because it's an elemental metals by itself. And then we have calcium chloride, which is calcium's in group 2A, it's going to be 2 plus. Chloride is in group 7A again, so it's 1 minus. We balance out the charge with a crisscross method. So here we have Ca Cl2. The last thing we're going to do is to make sure that the chemical equation actually balance out. So we have Ca, let me rewrite it again, plus Cu Cl2 produce Cu plus Ca Cl2. Let's make a list. We have Ca, Cu, Cl. Over here the same list so we can see them side by side. We have 1 Ca, we have 1 Cu, and 2 Cl, 1 Ca, 1 Cu, and Cl2. So it is balanced. So let's try another problem. We have sodium, that's the metals by itself, so we have Na, react with, so we use a plus sign, dihydrogen monoxide. This has prefix in it, and it tells you the numbers of atoms, so it's a covalent compound. So di is a prefix for 2. In this case, we have H2. Mono is a prefix for 1, so it's going to be O1. But we do not write the 1. To produce, so we have an arrows. Hydrogen gas, that would be your elemental gas, so it's going to be diatomic. Here we have H exists as diatomic molecules, and we have sodium hydroxide. Sodium is Na, and hydroxide is OH minus, okay? In this case, Na plus and OH minus. Now how do I know this is an ionic compound? Look, it doesn't have a prefix, so that's why we know right away it is an ionic compound. Now the charge is balanced, the negative and the positives already cancel out, and therefore we can just write like this, and we don't have to worry about that at all. So we have Na plus H2O equal to H2 plus NaOH. The last thing we have to do is to make sure our chemical equation is balanced. So we have NaHO, NaHO. Na is 1, H2O is 1, Na is 1, H2 right there, 1 right there, give you a total of 3. And here we have oxygen, just 1. All of them is balanced except for the hydrogen, but this problem is tricky because we have hydrogen right here and we have hydrogen right there. So the key to this problem is to make sure that the number here for hydrogen is even. If you notice right here, we have a 2 right there. Any number multiplied by 2 will give you an even number, but that even number will add 1 to here, will give you an odd number. So we're going to focus on here. Now 3, the next even number is 4. So we have 1, we increase by 1 more, will give you a total of 2. 2 plus 2 gives you 4. Now the question is this: 1 times what will give us 2? And of course the answer is 2. 2 times 1 give you 2 hydrogen, plus 2 over here give you a total of 4. This 2 affect the Na as well, give us 2 Na. This 2 also affect the O, of course give us 2 oxygen. And then over here, we're going to go back to balance the metal first. Always balance the metal first. So we have 1 Na, 2 Na. So of course, 1 times what will give us 2? And of course, the answer is 2. That gives us 2 Na. And then we go to the hydrogen. We have 2 and 4. We have hydrogen right here and the number 2. So 2 times what coefficient will give us 4? And of course, it is 2. 2 times 2 give us 4. But that 2 also affects the O, and therefore it gives us 2O as well. And it turned out it is balanced.